Okay, let's check out a little bit more general form. Instead of just restricting ourselves to y equals x squared, which is what we're looking at right now, let's play around with this general, often called standard form, y equals ax squared plus bx plus c. So this is a cool desmos demo where you can just move these little sliders and change the values of a, b, and c and figure out what it does to your graph. So let's go ahead and play around. So like I said, right now I'm starting with a equals 1. So this is a 1x squared down here. And b is 0, so there actually isn't an x term. And c is 0. So we really are just looking at y equals x squared. So let's play around with the a first. So if I start to make a bigger, you can see it looks like my graph is getting skinnier. What I would actually say is happening is that it's getting taller. It's just that my window is a fixed height, so that might not be what it looks like, but steeper for sure. This makes my graph steeper. And if we play around a little bit more, we can go back, whoop, right there. Okay, so if a equals 0, we no longer have a quadratic function because if a is 0, there isn't an x squared at all. So when we talk about this ax squared plus bx plus c, one of the rules is a can't be 0 or it's not quadratic anymore. And then interestingly, if a is negative, it flips the parabola upside down. Otherwise, same as above, the bigger a values make it steeper, the smaller a values make it flatter. In fact, you can make it pretty darn flat. But basically, this number out in front, one of its big jobs is to tell us whether the parabola opens up and looks like a smile. So positive a values give us a smile. Negative a values make it open down. So negative a values give us the frown. Let's go back to a equals 1. It also tells us something about how steep the graph will be. So if we think about that basic shape of y equals x squared that we're supposed to try and always keep in our head, if a is bigger than 1, it'll be steeper than that. And if a is between 0 and 1, it'll be flatter than that. Okay, I'm actually going to skip B because it's the most subtle. C, let's play around. C equals 0 right now. If I start to increase C, notice the graph doesn't necessarily appear to be changing shape. It's just sliding up the y-axis. And if I make C smaller, it looks like we're just sliding down the y-axis. So the way I would say this is that C will tell you where your y-intercept is. And that doesn't even necessarily have to be just a fact to memorize. Remember that if you would like to find a y-intercept, no matter what kind of function you're working with, you let x equal 0. So we're going to get a times 0, which is 0 no matter what a value we have, b times 0, which is 0 no matter what a value you have, or b value you have. So now all of a sudden this is all gone and we're left with y equals c. So when x equals 0, y will equal c. So c tells us the y-intercept of our graph. And making c bigger will move our graph up, and making c smaller will move our graph down. Okay, B's a little more subtle, but I think still worth playing with. As I move B around, it's interesting. The graph moves, it looks like it's moving to the right and down. If I move B the other direction, it looks like the graph is moving to the left and down. So it's kind of affecting both up and down and left and right. Since this is a class for mostly people who are headed to calculus, I'll tell you what calculus would say about B. C is determining where we cross the y-axis. So notice we always hit this point 0, 0. One way to think of B is B tells you how steep the graph is when it passes through the y-intercept. So that's one way to think of it. I don't know if that helps or not. So notice positive 2.5, that means we have a sort of steep positive slope when we cross through the axis. If B is negative 3, we have a sort of steep negative slope when we cross the axis. If B is, let's make it like 1/2, maybe, Okay, close enough. There we go. You have a shallow positive slope where you cross the axis. So that's one way to think about it. But I would say in standard form, B is a little less useful. And this is the thing, each of the forms have useful information that should be immediately clear once you learn how to look for it. So B is not telling me something that's quite so clear, but A is very clearly telling me whether the graph opens up or down and whether it's fairly steep or fairly flat. C is very clearly telling me where I cross the y-axis. So those are the powerful pieces of information that you get from standard form for free. Other good pieces of information are exactly where the vertex and the x-intercepts are, and we can use general tricks to find those, but they're not immediately obvious just looking at the equation. You'll just have to do a little work. So for x-intercepts, you're going to set this equal to 0, and for vertex, you can either put it in vertex form or you can use the formula, the x-coordinate of your vertex is negative b over 2a. So we'll do a bunch of examples where we find that, but this is just a little exploration. Thanks for watching.